Hey guys, I wanted to go over a very important topic in calculus, one of the core concepts for calculus, which is limits. And really I wanted to talk about what is a limit. I think we get into the class very often and we have to start solving them and calculating them and figuring out how to cancel different terms in order to solve limits, but we never actually talk about what's going on. So I'm going to give sort of a practical example of why we need limits, especially as it relates to the derivative, which actually is a limit itself. So let's imagine we are traveling, and we're traveling from city A to city B. These cities happen to be exactly 200 kilometers apart. Okay, so 200 kilometer distance between A and B, and we are going to take 2 hours to drive that distance. 2 hours. In fact, let's put some starting times and some ending times. So I'm going to say I leave at 1 p.m. and I arrive at B at 3 p.m. Okay, so the question becomes, how fast did I travel there? 200 kilometers, it took 2 hours. Pretty simple formula for speed. Speed we know equals the change is the triangle, in distance over the change in time. So my change in distance, I changed my distance by 200 kilometers. I traveled 200 kilometers in 2 hours. So I went, on average, I went 100 kilometers per hour. So that's how you get your speed, right? The change in distance over the change in time. Now, anybody could clearly see that this is going to take 100 kilometers per hour speed in order for this to happen. However, of course, in reality, when you leave city A and as you approach city B, you're not actually going 100 kilometers an hour for the whole time perfectly, all across the 200 kilometers. You're going to start probably slow, speed up to around 100 kilometers an hour, maybe pass some cars on the freeway where you're going much faster, slowing down, starting, whatever it might be. But on average, over that 2 hour period, you're traveling 100 kilometers an hour. Now, let's narrow down and pick a small section. Let's say from 1:30 till 2 p.m. I want to know on average how fast was I going in that period. And I'm going to say that I covered, let's say this is 60 kilometers. So again, we now have a half-hour period where I want to see on average how fast was I going during that time. So I'm going to use the same formula. Speed equals change in distance over change in time. The change in distance is 60 kilometers. The time is half an hour, so I'm going to use 0.5 because I'm using hours. 60 divided by 0.5 is 120 kilometers an hour. So during that section, just between 1:30 and 2, I was going on average 120 kilometers an hour. Let's keep this pattern going, and what we're going to do is narrow down the focus so much so that we're actually just at one point in time. So I'm going to say, let's say I'm going to pick a time, 2:21 p.m. Right at that point, I want to know how fast I'm going. And we know there's an answer for this, right? If you were driving, you could stop at any point, look at the speedometer, and there would be a speed that you're actually traveling. The problem becomes, how do we calculate that? Because we know speed as being the change in distance over the change in time. Well, if we're at just one moment in time, there's not a difference between 2 points in time. So our formula would be speed equals the change in distance over the change in time is 0. What's the problem with this is that we cannot divide by 0 and get an actual answer. Plug any number in, hit divide by 0 in your calculator, and you'll get an error. We're not allowed to divide by 0 in math. So, however, again, there should be an answer for this. So the question becomes, how do we effectively get this gap in time down to basically 0 without actually plugging in 0? And the answer is limits. So what I want to do is I want to take the limit as the change in time goes to 0, approaches 0, of this change in distance over the change in time, and that will give me my speed at that one point in time. We could go further into detail, and this would talk about the derivative and how it's the instantaneous rate of change, but this is a concrete example as to why we need limits. the change in time actually isn't ever going to equal 0. There technically will be just the smallest millisecond fraction of difference so that we can actually still use this formula, but limits allow us to see, okay, what's this pattern going towards as that change in time shrinks down to 0. Hopefully that's a helpful example. You can always see more videos on our YouTube channel, youtube.com/Arnold Tutoring. Thanks so much.